Good morning, good afternoon, good evening from whichever location you are watching this video. So what are we discussing today? Today we are discussing that abstraction is not abstract classes. Let me stress that, from my bottom of my heart, that abstraction is it is not an abstract class, right? See, when you talk about C# interviews, there are those small things, which can sometimes change the interviewer's perspective about a candidate. What exactly is an interview? An interview is a 30 minutes of discussion, or must be maximum on a 1 hour of discussion between two mature people. And sometimes in a flow, we say something, and this something, can have a devastating effect. So in this video, I'm covering one of those questions, and when I ask this question to developers out there, I get answers which is like, oh, why did he answer that, right? So the question is, what is abstraction in object-oriented programming? And many developers, with all respect, and senior developers, say that abstraction is abstract classes. Abstraction is abstract classes. Now, with that answer, you have no idea how much destruction you have done. So in this video, let us try to understand what is abstraction and what is abstract class. And let us conclude that abstraction is not an abstract class. And please, down below in the comments, if you feel that there are those small things, during the C# interviews or SQL Server interviews you come across, which can really change a perception, please write down in the comments. I would create a video around the same. So let us understand that abstraction is not abstract class. It is just that word abstract is same, or else, the meaning is completely different. So let us first start with abstraction. Abstraction is an object-oriented programming principle. It is a principle, it is a guideline, it is a rule, and by following that guideline and by following that rule, your code becomes better, you can manage your projects better, you can manage your classes better, and so on, right? So abstraction says that show only the essential features of an object. Talk about only the essential features of an object. For example, if you say you want to implement tax calculation, so you will say, okay, for tax calculation from the 30,000 feet level, what do we need? So we need an amount and we need a calculate process. That's it. Now at the back end, you are doing a GST calculation, or you are doing a TDS calculation, or you are doing some other tax calculation that we shouldn't be getting into. Right? So we should just get into the what part, the planning part, the 30,000 feet level, saying that what is the most important thing we need for a tax calculation, right? And how do we implement that? We implement that by using an interface, right? So when you think about abstraction is a thought process where you think about the 30,000 feet level. You think from the 30,000 feet level, what are the most important things for that class, for that object, right? And you start with an interface, because interface is a place, where you can have empty methods, empty properties. So you can, just think without any implementation, right? So I will say here iTax. So what are the most important things for tax calculation? The first thing is we need an amount, right? So we need an amount, right? And we need a calculate method which will actually calculate taxes, right? That's it. Now you can see I'm thinking very generically. I'm thinking from the 30,000 feet level. I'm not thinking about that this will go and calculate GST, or this will calculate IGST or CGST or a TDS. I'm just thinking that tax calculation, and what are the most essential features? We need an amount and we need a calculate method. Now let's talk about abstract class. An abstract class is a half-defined parent class. It's a half-defined parent class. So let us say that if you are there in a family of classes, where you have a parent-child relationship, if your child classes are having a lot of things in common, those common things you can put it into an abstract class. For example, when we talk about this tax calculation, right? For this tax calculation, the calculate method is different. So if you say you have CGST or IGST or GST or TDS or something else, right? The calculations can be different, but all the tax calculation will have one thing in common, that they don't want amount to be zero. So what you can do here, you can go and you can create an abstract class. So you'll say here, this is like a base class, an half defined class, right? So, and you will implement iTax, and over here you will say that I will define some logic, and some logic has to be defined by the child classes, right? So we'll say here, okay, for the amount, so we'll say here, if the value is 0, then throw an exception. So now this logic for all the child classes, whoever are doing tax calculation, this logic is common, right? And the calculate method, you will leave it to the child classes, right? So you will say here, okay, the child classes, well, they will define further how the calculate method will work, right? So you can see here, this is an abstract class, and half defined parent class, where some logic is defined and some logic the child classes will define, right? This is also termed as generalization, specialization. So all across the classes, you have some general logic. Now the classes will go and define their special logic, right? So you will say, okay, public class, let us say GST, will inherit from base class, and then you will say here, okay, override the calculate, and you will put the calculation logic out here for GST calculation logic will be written out here. In the same way, you will have, must be a TDS calculation, right? Now in case of a TDS calculation, it will have its own TDS calculation logic. So you can see here, this abstract class is actually it's actually a type of a class in C#, and the type of the class helps you to define a half defined logic, right? A partial class and half defined thing at the top, and then the child classes go and define the full implementation, right? So it's a half implementation, right? So let us now try to differentiate. Abstraction is an object-oriented programming principle, right? It is a 30,000 thought process. It is a 30,000 view of the most essential properties of an object. And how do we implement it? Actually, we create an interface. Why? Because in case of an interface, you can define everything without any logic, without any property, just signatures. You can use the interface to just define a concept, right? So it is just a 30,000 feet level of what are the most essential things, while abstract class is a half defined parent class or partial class, where some things are defined at the parent level and some things are defined at the child level, right? The full implementation is defined at the child level. So please note, abstraction is not abstract class. Also, let us try to get to the root cause of the problem. Why do such kind of things happen during the interview? Why does a developer think that abstraction and abstract classes are same, right? First thing, let me tell you, a developer who thinks that abstraction and abstract classes are same does not mean that he cannot code in projects. He must have delivered big projects, I'm sure about it, right? The only thing, what probably he is not doing is he is not revising. He is not revisiting the principles. He is not revisiting the fundamentals, right? See, when you're working in a company, most of the time you're sending emails, you are talking to clients, right? You're handling issues, you're fixing bugs. You're not learning. You're not learning. There is a difference between learning and working, right? So what I feel is that a revision is essential. If you're going to an interview, it is important that you should revise. It is important that you should revisit your fundamentals. It is important that you should smoothen your vocabulary, right? So here it is, guys, on questpoint.com, we have a complete C# interview question with answer preparation course, which is like 100 questions I have covered with code demonstrations, with proper answers, how to answer them, what kind of cross questions you will get, right? So please go ahead and subscribe, to this course out there. This course, you can get it on questpoint.com. You can get it on Udemy. You can get it at many other places. All those I have put down in the description section. Also, if you really want, right, what you can do is that in this channel itself, I have a 1 hour of video free where I've taken the first 30 questions. So first 20 to 30 questions I've covered in this channel itself. So must be, if you're preparing for C# interviews, you can go through that video, right? So remember, one sentence, before I end this: a prepared developer has more chance of getting success than an unprepared superhero. You can be a superhero in your project, but it does not mean that you will crack interviews, right? So before I end this session, here's a small request. So if in your experience, if you have come across any one of those small things, where as an interviewer, when you interviewed a candidate and that small thing changed the perception about the candidate, right? Or where you went as a candidate and gave an embarrassing answer and which you later felt like I shouldn't have answered that, right? So if you have those moments, if you have those questions and answers, please put down in the comment section. I will definitely try to create a video of it, right? So happy learning, happy job hunting. I do understand that money is not everything, but money is something which makes our life better, right? So be billable, be on a good job, have a happy life. Thank you.